Good evening, Suraksha. Good evening, Abhirup. So it's 4:45. Let me begin my class. Just hold on. Okay. So in this class, we will learn about intermolecular forces. Intermolecular forces. Now the fact is this that there are two types of forces, that is in this respect intermolecular forces, which determines the strength of which, or the nature of which determines the physical property of the substances. And then there are intramolecular forces, which the nature of which determines the chemical properties of the substances. So there are two types of forces, intermolecular forces and intramolecular forces. Intramolecular forces are covalent bonds, ionic bonds, coordinate bonds. Means the force of attraction between an ion and another ion inside a molecule, or as for that matters, the force of attraction inside that molecule, covalent bond or ionic bond, or there may be coordinate bonds. So these covalent, ionic or coordinate bonds are called intramolecular forces, and the nature and the strength of these forces determine the chemical properties of the elements, that how they will behave chemically, what kind of chemical reaction they will do, and all these sort of things. But however, the intermolecular forces are forces, suppose if there is a molecule and if there is an interaction between the two molecules, suppose this is a molecule and this is a molecule, and there is a force of interaction between this positive and negative molecule, then such type of forces are called intermolecular forces. The forces of attraction or repulsion existing among the particles of a substance, the forces of attraction or repulsion that exists between the particles of a substance, be it in gaseous state, be it in liquid state, be it in solid state, okay, other than the electrostatic forces that exist among the oppositely charged ions, and forces that hold atoms of molecule together, that is, for example, the covalent bonds, are called intramolecular forces. Okay. And so I hope that you understand that intermolecular forces are the forces of attraction between two different molecules. So that is for sure. Now there can be various types. Now they have mentioned that ionic bond is not allowed. I mean electrostatic forces are not allowed. Electrostatic forces are not allowed. Electrostatic forces are not at all not allowed in the understanding or the classification of intermolecular forces. That you have to keep in your mind. Now when you keep that in mind, the intermolecular forces, the types of intermolecular forces that you will experience are: number one, dipole-dipole interaction; Now question arises that what is dipole-dipole interaction? See, one classic example can be given with HCl. Suppose there is HCl and you know Cl, this is intramolecular force. The force holding H and Cl atom together is intramolecular force. That is a different thing. But now I'll talk about intermolecular force, which one type is dipole-dipole interaction, where H can be delta positive and Cl can be delta negative. Now when this happens, if H is delta positive and Cl is delta negative, you know, if there is another one where H is delta positive and Cl is delta negative, then there will be a force of attraction between this H and Cl. Now why is it called a dipole-dipole interaction? Because whenever there is charge separation in a small distance of opposite two charges, we call that entire thing as a dipole. Hence HCl is also a dipole. Now the other question arises that why there is charge separation in HCl. The reason that there is charge separation in HCl is because Cl is a very small atom and hence it pulls the bonded pair of electrons towards itself. It pulls the bonded pair of electrons towards itself, and because it pulls the bonded pair of electron towards itself, it slightly becomes delta negative and it slightly becomes delta positive. This property of chlorine of pulling the bonded pair of electron towards itself is known as electronegativity. So this is due to electronegativity, that there is existence of dipole in a molecule, and the dipole of one molecule interacts with the dipole of another molecule, hence it is known as the dipole-dipole interaction. These forces of attraction holds the molecules together. So I hope that you have understood this dipole-dipole interaction. Now a serious question arises that on what factors does the magnitude of the dipole-dipole interaction depends. So the question that arises is, on what factor does the magnitude of a dipole-dipole interaction depends? Okay, on what factor does the magnitude of a dipole-dipole interaction depends? Now, the factors on which the magnitude of the dipole-dipole interaction means, suppose there is a molecule AB, there is a compound AB, and A is slightly positive, that is delta positive, and B is slightly negative, that is delta negative, and suppose there will be lot of molecules of AB surrounding AB, so some will be delta positive and it will be delta negative, and hence there will be force of attractions and repulsions everywhere. Okay, so if we consider this, then if we consider that there is another CD compound and it also has dipole, D plus, CD plus and D minus, delta minus, okay, and there is another C delta plus and another D delta minus, then what happens? There is force of attraction. Now this force of attraction is greater or this force of attraction is greater? Which one? On what factors the magnitude of dipole-dipole interaction depends? Is the dipole-dipole interaction much more greater in the AB compound, or is the dipole-dipole interaction much more greater in the CD compound? What is it? Now if you try to understand what are the factors, the factors are on the basis of, the answer is, the factors are on the basis of the polarity of the molecules. The polarity of the molecules. On the basis of the polarity of the molecules. Okay, so that is one basis. Now you see, polarity of the molecules depends on what? Depends on which in turn depends on the electronegativity of the atoms present inside the molecule. So that also you should keep in mind. So This is one thing. So that means if AB is there, if B is more electronegative than A and D is more electronegative than C, but the comparison, if you see, if B is comparatively more electronegative than A as compared to D than C, okay, suppose B is much greater electronegative, much greater electronegative than A, and D is just greater electronegative than C, then the dipole created here, D negative and D positive, and here, okay, it will be much, the separation will be much high, and as because the separation will be high, the strength of the dipole will be more, and as because the strength of the dipole will be more, the dipole interaction in the AB compound, the dipole interaction in the AB compound will be higher. So this is one factor on which it depends, that electronegativities of the atoms. And another thing that it depends on is, second, is geometry of the molecule. Now whatever is the geometry of the molecule, on that basis also, what we can say, the strength of the dipole interaction differing from one compound to another can be understood. But the factor of geometry only dominates for polyatomics, polyatomic molecules, not diatomic molecules like them. If is suppose you have taken diatomic molecule, diatomic molecule, only this factor will dominate. But if you take polyatomic molecule like PH3, H2S, okay, then like CO2, then this the geometry of the atomic molecule also, I am not saying that in that case this factor will not dominate, that the how much electronegative and how much the charge separation is, this factor will also affect, but along with this factor will also affect, geometry of the molecule will also affect, which you should keep in your mind. Now moving forward with our understanding that, okay, fine, first thing that you should understand is, suppose for example, depending on the electronegativity or or the strength of, on the basis of the polarity or the strength of polarity, and geometry, mathematically a unit is there, capital D, to measure the dipole moment. The dipole moment. Now what is dipole moment? This you will learn, I hope you will learn in class 12 physics. You will learn this, to the mathematical thing, that the unit that was used. Okay, so that is a different thing. But yes, I hope that you understand that if I say that the dipole moment, more the dipole moment means more charge separation is there. If the dipole moment, if I say of PH3 suppose is 0.55 D, and suppose for example of H2S is 1.10 D. Okay, so this I hope that you understand that this will have a much more larger dipole and this must have a much more smaller dipole, and hence dipole interaction in H2S will be much more stronger than the dipole interaction in the PH3. That means intermolecular force of attraction in H2S is higher than the intermolecular force of attraction in pH3. Now that can be true for a lot of pair of molecules. However, in the example of H2S and PO3, we find that both of them are polyatomic molecules. So that means their dipole moment shouldn't have dependent only on the strength of the polarity, but also the geometry. Now the fact is this, that we see that this is more and this is less. So what happens is that in case of H2S, we generally find a little bit bent structure, not linear at an angle, but a planar kind of structure. But in pH3 you will not find a planar structure. In pH3, pH3 is actually, there are 3 H's, and hence it will form a 3-dimensional structure. The details of these structures you will learn in chemical bonding just from the next day, okay, which will be your beginning point. But I hope that you understand that I don't know, in class 10 I had said this previously. I used to say to the class 10 people also, suppose CH4, when I teach, I tell them that CH4 is tetrahedral like this. Okay, because of sp3 hybridization. Same is the case of pH3. Now if it is a planar, it will not be that much rotating molecule, but if it is 3-dimensional, it will be a rotating molecule. Okay, so that is one thing that you should understand. So it was found by Kiesom, the scientist Kiesom. It was found by the scientist Kiesom, and hence dipole-dipole interaction is also known as Kiesom forces. That static molecule, if it is there, then dipole moment is inversely proportional to 1 by r cube. But if there is a rotating molecule, then dipole moment should be proportional to 1 by r to the power 6. Now it is very easily seen that if I consider dipole moment of static molecule ds is inversely proportional to 1 by r cube, and that of rotating molecule dr, dipole moment of rotating molecule, 1 by r to the power 6, you can obviously see that the dipole interaction in case of a static molecule will be much more higher than that of a rotating molecule. Right or wrong? From this, if you little bit mathematically think this, I should not go into the deep explanation of this because you have passed your class 9 and 10. I hope you understand that r cube and r6 correlation and inversely proportional what it is. So think properly, you will find. So I can understand that in H2S and pH3, not only because of the more electronegativity of sulfur than hydrogen in comparison to electronegativity of phosphorus to hydrogen, you see what happens is there is more polarity, first thing, okay, and hence also due to the geometry it has more dipole forces. So these are the results of this statement that I have these are the reasons for the statement that I have written here, that intermolecular force of attraction in H2S is higher than that of the intermolecular forces of attraction of pH3, and its proof is that the boiling point of H2S is minus 61 degrees Celsius and the boiling point of pH3 is minus 88 degrees Celsius. The melting point of H2S is minus 86 degrees Celsius and the melting point of pH3 is minus 134 degrees Celsius. Now what does this prove? This proves that if the boiling point is higher and in the melting point is higher, there are strong forces of attraction. What is boiling point? Boiling point means, suppose when it will boil, that means convert from liquid to vapor. Okay, so in liquid molecules are more kache kache. In vapor, they in boiling point they absorb the energy to overcome the intermolecular force of attraction so that they can move dure dure to convert into vapor. And hence, as because the dipole interactions are more and the intermolecular forces of attraction is high compared to the pH3, whatever the intermolecular forces are, it is more. So you need more energy to bring them apart and less energy to bring them apart, and hence the boiling point going from liquid to vapor, on the melting point going from solid to liquid, same thing. is tougher than that of pH3. pH3 में इतना टेम्परेचर आने से ही मेल्टिंग और बॉइलिंग स्टार्ट हो जाएगा, इसमें और हीट अप्लाई करना पड़ेगा, फिर मेल्टिंग होगा, इसमें और हीट अप्लाई करना पड़ेगा, फिर बॉइलिंग होगा, इसीलिए उससे हायर है. So I hope that you have understood this thing. So tell me in comment section, the 4 of you or 2 of you are saying that have you understood this. I'll take a little bit of rest. I have talked for 21 minutes. In comment section, please tell me. Good, Suraksha. Thank you. So, okay, very good. So, if you have understood, now moving forward with ion dipole interactions. Second type is ion dipole interaction. Now, if what happens in case of ion dipole interactions is that there is a concept, I'll first name the concept, that is hydration of ions. If we understand that what is hydration of ions, then we will understand ion dipole interaction very well. Suppose for example, sodium chloride, NaCl, which is a compound containing ions Na plus and Cl minus. Suppose what happens is that if you put them in a polar covalent compound, in a polar solvent, now the Na plus is there, the Cl minus is there, the water molecule, if I imagine OH, it is slightly delta negative, it is slightly delta positive, it is slightly delta positive, because oxygen ion is electronegative and pulls the bonded pair of electron towards themselves or itself, and hence these H2 molecules will surround. Now it will surround Na in this way, OHH, 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 OHH. And if I talk about chlorine, just hold on. And if I talk about chlorine, they will surround H plus, O minus, H, another H plus will be here. So it will be like H plus, here O minus, and from here H plus. Bond, okay. So like this, H plus, O minus, H plus. But you know what will happen? This thing that you are seeing, this is interaction of ion and dipole, because the ion is interacting with the dipole. Yes or no? When the ion is interacting with the dipole, we will call it ion dipole interaction, and this process that is happening is known as hydration of ions, because the ion is getting surrounded by water molecules, and hence it is known as hydration of ions. Got my point? Hence it is known as hydration of ions. So I hope that you have understood. And also from this logic I can tell that if you put NaCl inside CCl4, okay, you will find CCl4 is a non-polar molecule, non-polar solvent you can say. And if you put NaCl, NaCl will not be soluble only. So remember, hydration is also important for solubility. Hydration of ions is important for solubility. The more the effect of the hydration, more will be the solubility. Okay, so that thing you should understand. Now I hope this is okay. Now one more thing that I would like to say, that on what factor the strength of the interaction depends, always as usual. What are the factors? What are the factors on which the strength of the interaction of ion and dipole depends. This means number one is charge and size of the ion. Charge and size of the ion. And number second is magnitude of dipole moment. Dipole moment. Second is the magnitude of the dipole moment. And third is the size of the polar molecule. Let us take up all these points one by one and try to explain it. See, if I put, if there is charge on the ion, suppose Na plus ion is there, and Al in the sodium, then in the period of sodium, magnesium is only there as positive ion. So if you take sodium ion and magnesium ion, both in the same period, if you remember, both lie in the same period. I think I have talked about size of atoms in my video of periodic classification that I have already sent you. Yeah, that is already talked. So in same periods, the size remains same. So almost if you think that the size is same, though Na plus and Mg size is not the same, but still I can understand. But here we can see the charge is more. So it will be hydrated easily. Now this is one thing. So charge and not only charge, greater the charge, then hydration will be more. It also depends on the size of the ion. Now among Na plus and Mg2 plus, whose size is greater? Now if I try to analyze, if Na plus takes one electron, suppose this is Na atom positively charged, and there is nucleus and there are shells. Two, 8, I am drawing the bacha style, 1, 2, 3, 4, 5, 6, 7, 8 and 1. Now when it loses then one electron, the, you know what to say, the attractive force per electron ड्यू टू लॉस ऑफ वन इलेक्ट्रॉन इंक्रीजेस, बिकॉज इसको और अप्लाई नहीं करना पड़ेगा, इसका जो है वो भी इन लोगों में डिवाइड हो जाना है, तो ओवरऑल इंक्रीजेस. लेकिन क्या हो रहा है कि मैग्नीशियम का अगर लोगे तो भी यहाँ पे 2 इलेक्ट्रॉन लॉस्ट होगा. तो 2 इलेक्ट्रॉन लॉस होगा तो भाई एक का जब नहीं रहा है उतना अट्रैक्टिव फोर्स अगर इनमें डिवाइड होगा तो ये भी 2-8 बन रहा है, इसमें 2 का नहीं है, 2 जन चला गया है, वो जब इनमें डिवाइड होगा तब क्या होगा, ये इसमें पुल ज़्यादा होगा कि इसमें पुल ज़्यादा होगा. डेफिनेटली Na से Mg में पुल ज़्यादा होगा. डेफिनेटली Na से Mg में पुल ज़्यादा होगा. क्यों? क्योंकि ये 1 इलेक्ट्रॉन छोड़ के 2-8 बन रहा है, ये Mg 2 इलेक्ट्रॉन छोड़ के 1 इलेक्ट्रॉन छोड़ के 2-8 बन रहा है, Mg 2 इलेक्ट्रॉन छोड़ के 2-8 बन रहा है. तो 1 इलेक्ट्रॉन में जो अट्रैक्टिव फोर्स काम कर रहा था वो अब निकल जाने के बाद रहा नहीं, तो वो अट्रैक्टिव फोर्स इनमें डिवाइड हो गया है और ये इसमें 2 इलेक्ट्रॉन चला गया है और 2 का अट्रैक्टिव फोर्स इनमें बट रहा है. तो इसका मतलब क्या हो रहा है? इसका मतलब ये हो रहा है कि इसमें ज़्यादा फोर्सेस अप्लाई होगा क्योंकि 2 का बट रहा है सब में. राइट और रॉन्ग? 3 तो ये ज़्यादा छोटा होता जाएगा. ठीक है, तो चार्ज ऑफ आयन इज, तो चार्ज ग्रेटर होने से भी साइज स्मॉलर है. अब साइज़ जितना स्मॉलर होगा साइज़ ऑफ द आयन के ऊपर डिपेंड करेगा. अब देखो बात ये है कि साइज़ जितना स्मॉलर होगा उतना ना चार्ज डेंसिटी ज़्यादा हो जाता है. जितना साइज़ स्मॉलर होता है, साइज़ स्मॉल मीन्स चार्ज डेंसिटी इज़ मोर. क्योंकि एक छोटा सा जगह में, एक छोटा सा इतना बॉल में अगर पॉजिटिव चार्ज, सेम अमाउंट ऑफ पॉजिटिव चार्ज और इसमें अगर सेम अमाउंट ऑफ पॉजिटिव चार्ज डिस्ट्रीब्यूट करो तो किसमें इसमें चार्ज डेंसिटी ज़्यादा होगा, राइट और रॉन्ग? ठीक उसी तरह ये जो एक फैक्टर है, सोचो तुम Na+ और Cl- को पानी में घुला दिया, Na को ज़्यादा वाटर मॉलिक्यूल घेरेगा, Cl को कम वाटर मॉलिक्यूल घेरेगा। ऐसा क्यों है सर? क्योंकि when anions take electron, they become bigger than the atom. सपोज फॉर एग्जाम्पल क्लोरीन का सोचो, पॉजिटिव चार्ज है, 2 इलेक्ट्रॉन था, यहाँ पे 7 इलेक्ट्रॉन है। अब इसमें अगर 1 इलेक्ट्रॉन घुसेगा, सोचो अभी घुसा नहीं है, अब ये पॉजिटिव चार्ज सब में अट्रैक्टिव फोर्सेस डिस्ट्रीब्यूट कर रहा है। अब एक अगर बढ़ जाएगा तो डिस्ट्रीब्यूशन ऑफ अट्रैक्टिव फोर्सेस इसमें भी हो जाएगा, तो सब में लगभग कम हो जाएगा अट्रैक्टिव फोर्सेस। 5 जन जो खाना खा रहा था अभी 6 जन को देना पड़ेगा। तो ठीक उसी तरह ये थोड़ा सा अट्रैक्टिव फोर्सेस कम होने की वजह से साइज़ में बड़ा हो जाता है। तो इस वजह से ऑलवेज पॉजिटिव आयंस, और ये सेम ग्रुप में है सोडियम और क्लोरीन, ठीक है, दोनों का 3-3 शेल्स है। तो अभी तो इसका मतलब ये हुआ कि हमेशा anions are smaller, anions are greater or bigger in size than that of cation, and hence what happens is they become little bit more have more charge density, ठीक है। इसके अंदर मोर चार्ज डेंसिटी होगा, इसमें कम चार्ज डेंसिटी, Cl में कम चार्ज डेंसिटी होगा। तो ये हुआ बात, तो इसलिए इसको ज़्यादा घेरता है, इसको कम घेरता है। तो ये हो गया व्हाट इज़ आयन डाइपोल इंटरेक्शन, और ये आपका हो गया कि आयन डाइपोल इंटरेक्शन का मतलब क्या है, एंड यू अंडरस्टूड द फैक्ट। ओके, सो एंड व्हाट फैक्टर्स इट डिपेंड्स ऑन। तो ये हो गया आपका। अब है नंबर 3rd टाइप, आयन इंड्यूस्ड डाइपोल इंटरैक्शंस। आयन इंड्यूस्ड डाइपोल इंटरैक्शंस। अब अगर मैं आयन इंड्यूस्ड डाइपोल इंटरैक्शंस में जाऊं, 2 मिनट रेस्ट ले लेता हूं, रुको। Oh, I forgot to discuss this. Magnitude of dipole moment and size of the polar molecule. Obviously, polar molecule का size जितना ज़्यादा होता जाएगा, अगर छोटा molecule के सामने गिरेगा तो उसका वो अपना इफेक्ट नहीं दिखा पाएगा। और magnitude of dipole moment, greater the magnitude of dipole moment, greater will be the ion dipole interactions, obviously. So these two are very easy, that's why I did not explain. I mean, I forgot to explain, sorry. Anyway, now let us go into ion dipole interactions. Now what happens in ion dipole interaction is that, suppose there is a presence of an ion NO3 minus. Due to the presence of this ion, there is a non-polar molecule, iodine, I2, or maybe nitrogen, N2. Now what happens is, due to this, when from whichever side it comes, the electron density that is being distributed here, if I talk about electron density, that is in bonding, what happens, electron density means the electron waves or the orbitals are here. Okay, so when the orbitals are there, so electron density is like this, electron cloud is like this, we call it electron cloud. Electron cloud is like this. So what happens, this is pulled towards this, I mean this is repelled by this negative charge. Suppose there is a II and there is electron density. Suppose there is a positive ion, suppose Al+3, then there will be an attraction in this side. From whichever side it is there, it will be, what is happening is, normally if it is staying, nobody disturbs this and it doesn't become polar. But if there is a presence of a positive charge and a negative charge, the electron cloud is either attracted or repelled, and due to that what happens, it gets induced into a dipole. It gets induced into a dipole, and when it gets induced into a dipole, then we call it induced dipole, and it is induced by an ion, so we call it ion induced dipole interaction. So there will be interaction between the ion and the dipole. This is an interaction or example of an interaction of the ion and dipole. Now the question arises same, on what factors does the strength depend? Or ion induced dipole depend? On what factors the strength of the ion induced dipole depend? That is what we have to understand. So the strength of the ion induced dipole depends, we can say that the charge on the ion and the ease with which the nonpolar molecule gets polarized. Number one, charge on the ion. Obviously, more will be the charge on the ion, more the electron cloud will be attracted or repelled. And also it depends with the ease with which the molecule tends to be polar. Okay, so these are the two things that it depends on. Yes, obviously, if iodine has more easiness, or its electron cloud is more easy to be polar than that of nitrogens, then obviously their attraction and repulsion, it will respond to the attraction and repulsion more than that of the nitrogen, first thing. And second thing is that obviously iodine ka electron cloud will be more affected than nitrogen ka electron cloud, because nitrogen is a smaller molecule and nitrogen ka electron cloud will be small. It is very tough to distort a small electron cloud, and it is very easy to distort a big electron cloud. What do you think? Suppose in a balloon, if you take a small balloon and put water on it, when you try to do a random movement of it, the distortions that you will see. And if you take a bigger balloon and put water inside it, and if you try to move it, the bouncing and the distortions that you will see will be more easy to happen in a bigger balloon with the water, right or wrong? So that is the concept, or that is the physical, visualization that you see, or understand that a bigger molecule must have more distortion due to bigger electron cloud than the smaller one. So it depends on the ease with which the molecule tends to be polar. So I hope that you have understood up to this much. Now tell me in comment section, have you understood the ion dipole interaction and ion induced dipole interactions or not? Please comment and say. Is there any comment? Okay. Snehanshu said yes, he understood. So we will move into dipole-induced dipole interactions. So when we move towards dipole-induced dipole interactions, suppose for example there is a polar molecule AB. A is positive, slightly positive, and B is slightly negative, which we call polar. So it has a dipole moment, and it is a dipole. A presence of a dipole when distorts, suppose there is a noble gas atom, suppose there is sodium, sodium boli, neon, so or argon, so there is a noble gas ka electron cloud, noble gas ka single atom is there. Now due to the presence of this dipole, this will get distorted, like this it will become, as because the negative is pulling, the electrons must have repelled and gone this side, so it will become negatively charged and this side will become positively charged. This is what happens. Okay, so this distortion is known as a dipole induced dipole interaction, because this dipole induces a dipole, so that's why it is called a dipole induced dipole interaction. And what is the strength will depend? Their strength will depend on two things: the strength of the dipole and number two, the ease with which the molecule or the atom undergoes, or what to say, the tendency to get polarized. And if definitely this depends on the size, as you know, right or wrong, as I have just explained. So I hope that dipole induced dipole interaction is not tough. Now these forces can easily be perceived and easily can be understood. There is no problem in understanding these forces or perseverance of these forces, how you perceive these forces. But however, you see, what happens is that you also have to understand that there is another force which is known as the London forces or dispersion forces. Now perceiving this force becomes little bit tough, but I will ask you a question. H2, N2 molecule, O2 gas. Suppose there is a tumbler, there is H2 gas, all H2 molecules. Suppose there is a tumbler, there are all N2 molecules. Suppose there is a tumbler, or O2 molecules are roaming around. Okay, so when this is happening, okay, so they have intermolecular force of attraction between them. What force? Because they are neither polar, neither any. What is happening? Is this happening? I'll tell you. Wait. Is it so that there is what to say? First one, dipole interaction? No, because there is no dipole. Second, in H2N2 thing, okay, is there ion dipole interaction? No ion is present there. Is it ion induced dipole interaction or a dipole induced dipole interaction? No, nothing is there. So because no ion, no other dipole, nothing is present, still they have intermolecular forces of attraction. From where does this intermolecular forces of attraction exist? From where does this intermolecular force of attraction exist? From where? How do you think this intermolecular force of attraction exists? You see, what actually happened is because they are non-polar, I agree, but they have an electron cloud, right? Suppose there is a helium atom. So it has an electron cloud. Yes. 1s2 electron cloud. There is another helium atom, there is also electron cloud. Now what happens as they move around, okay, there will be little distortion in them. As they move around, there will be little distortion in them due to the force of the what to say, for movement of the electron due to the force of the movement of the electron. Means the electron is moving around. Okay, now you cannot imagine electron to be a particle, you have to imagine it to be a wave. But this charged particle, when is this moving around, there arises a force due to the motion of the electrons. And it is believed that any instant of time, the electron cloud, okay, this electron cloud that you see, the electron cloud molecule may be distorted so that an instantaneous dipole exists due to the motion of the electron. What happens for a very this distortion, then this is due to the motion of the electrons. I told you na, due to the you imagine water inside a balloon. So in whatever is that, if you imagine the water to be electron cloud inside the balloon and the balloon to be the boundary, if you take the balloon and imagine such balloon is alone, by itself, alone by itself dancing around, okay, like this. Don't you think that the water will also dance around inside and there will be little distortion by itself due to the motion of the electrons or the motion of the molecules itself? So due to that distortion, so one of the portion little bit gets negatively charged, where the water, the electron, bees more, and little bit positive charge. Here the probability becomes little bit more of finding the electron. So this instantaneous dipole will always exist. Now remember, this is instantaneous dipole. We call it a momentary dipole. A momentary dipole. See, note this thing, okay, or understand this thing. Please keep in your mind that the momentary dipole that is formed at one instant, at the next instant the dipole will be lost, will be different. Because the electron, it is continuously moving, the electron could have moved the opposite direction. It could be lost or the orientation may be changed. So over a period of time, the electrons move rapidly and the effect of these momentary dipoles are cancelled. And hence there is no permanent dipole. But as because that there is a dipole at every instant they are doing it, so at each of the instant some of the other molecules will be inducing dipole in the another one due to its positive and negative. Due to its positive and negative, it will be inducing, and it will also become like a dipole, and everyone at a particular instant will be a dipole, and hence there will be force of attraction between the dipole and the dipole. But these are dispersed dipoles, and hence these are called dispersion forces or London forces. I hope you have understood. Now tell me in comment section you have understood or not this London forces. Have you understood London forces? Please tell me in your comment section. Okay, very good. So now I know I hope you understand the obvious question that will arise. What is the obvious question that will arise? On what factors does the strength of the, on what factors does the strength of the dispersion forces depend? dispersion dispersion forces. On what factors are the dispersion forces depend? Let us try to understand. So the number one factor is complexity of the molecule. Complexity or size of the molecule. Now this is quite obvious. The bigger the size of the molecule, more the distortion will be there. Because I told you, think a big balloon, think a small balloon. Just what I have explained there. And second thing is, so bigger the size, bigger or complexer, or complex the size, more is the distortion, so greater is the dipole. Greater is the momentary dipole. Momentary dipole. Okay, just hold on for a second. I'll put my phone in charge. The greater is the size, more is the distortion, so greater is the momentary dipole. So I hope it depends on the size. This is the reason why in group 14, if you see CH4, if you see SiH4, and if you see GeH4, it has boiling point of 112 Kelvin. It has the boiling point of 161 Kelvin. And it has boiling point of 183 Kelvin. As because these are bigger in sizes and there are London dispersion forces of attraction, so the force of attraction holding these molecules, GeH4 molecules together, will be much, and hence the boiling point is high. Because more the attractive forces, more it will be try to be in the liquid or the solid state, and not allowed to, or must have more energy to be given to them so that the molecules get separated. So the boiling point increases down the group. So that you should understand. And second thing, that it is complexity of the size of the molecule. And the second thing on which it depends is the geometry of the molecule. Is the geometry of the molecule. Suppose, for example, you take the example of neopentane and N-pentane. This example will clear it. If you take neopentane is like this. It is kind of circular. And if you take N-pentane is like this. It is kind of, zigzag. So what do you think? If there are neopentane molecules and if there are N-pentane molecules, the interactive places will be more. The interactive places of the electron clouds or the London dispersion forces will be more, and due to the less surface area of the circular or sphere shape, what happens, the forces of attraction or the distortion will be less, and hence its boiling point is about 36.2 degrees Celsius and its boiling point is just 9.5 degrees Celsius. So I hope you have understood it is much more greater dispersion forces existing between neopentane. So it depends on the geometry of the molecule. So now finally tell me it is over. And always remember one more thing, that except the ion induced dipole forces, all are known as van der Waals force. Although this is known as London force, but it comes under the van der Waals force. London is the name of the scientist. Except for, as I said, except for ion dipole and ion induced dipole. So ion dipole, ion induced dipole and ion dipole, these two, except all that I have taught, are known as van der Waals forces. There is also another thing, hydrogen bonding. Hydrogen bonding is a simple thing. Suppose there is H2O molecule and suppose there is another H2O molecule. There will be delta positive and delta negative charge. and there will be force of attraction, or a seems, a force of attraction existing between this negative and this positive. This is hydrogen bonding. A bond gets created. Hydrogen bonds are stronger. Okay, so I hope that you have understood up to this much. Now we will move into the last topic of this chapter, which is liquefaction of gases. Let us talk about liquefaction of gases, but give me 1 minute time to take rest. Okay, let us begin with liquefaction of gases. Now, okay, see, we can liquefy gases. Liquefaction of gases means what? Converting gases into liquids, right? Now, when we go into the liquefaction of gases, when gases are converted into liquids, what actually happens is that you can do it by two ways. One is decreasing the temperature, and second is increasing pressure for compressing the gas. By decreasing temperature, you decrease the random molecular motion and make them bound to come closer to each other, so that the intermolecular distance becomes so much that the intermolecular distance comes to a range where there are attractive forces, and they convert into liquid closer. Okay, so by decreasing temperature or by increasing pressure, same thing you can do by applying pressure over the gas, okay, and bringing them closer. But it has been observed. What has been observed? It has been observed that above a particular temperature, of a gas, above a particular temperature of a gas, how much pressure you apply, the gas will not convert into liquid. It has been observed. In fact, gases like hydrogen, nitrogen, many more gases do not liquefy at room temperature. CO2, okay, they do not liquefy at room temperature. CO, okay, they do not liquefy at room temperature. They will not liquefy at room temperature. Okay, so because at room temperature the temperature is, you know, quite even if you keep on applying pressure, okay, so the temperature is not low enough so that, suppose you are applying pressure, suppose, let me give you an example for this so that you can understand. Hold on for a second, I'll just see the example from the book. Okay, suppose you are applying or operating at minus 50 degrees Celsius. Fine. At minus 50 degrees Celsius, you apply 6.7 atm pressure to CO2 gas, it will get compressed into liquid. But if you are doing the same thing at 20 degrees Celsius, the pressure that you have to apply, hold on for a second, yeah, the pressure that you have to apply at 20 degrees Celsius is 56.5 atm. Bapre. So that means at a higher temperature, even if you apply pressure, the random molecular motion needs to be at a range or little bit lower, you know, so that the pressure requires less. At minus 50 it is much more less, so less pressure hi hoye jacche. The liquid gets converted into gas. Oh sorry, the gas, I'm so sorry. The gas gets converted into liquid. But at 20 degrees Celsius the random molecular motion is much more, they are far away, so অনেক বেশি far away থাকে, তাহলে 56.5 atm pressure লাগতেছে. But if you go above 30.98 degrees Celsius, suppose you are operating at 31 degrees Celsius, how much pressure you apply? You apply 1000 atm pressure, it will not convert into gas. You apply pressure, the gas is at suppose 31 degrees Celsius or 32 degrees Celsius, you apply 1000 atm pressure, but the random molecular motion, which is dignified or signified by the temperature, is so high that even if you bring them closer, no, we are not going to convert into liquid. Now this effect is due to, I will tell you, because of whenever the gas gets converted into liquid, the liquid and gas exist in an equilibrium state. Okay, so like if you kind of you know, increase the temperature or something like that, what will happen is on increasing the temperature, the gas, you know, molecules, the substance will have or will try to exhibit nature of gas more than liquid. But if you lower the temperature, then it will try to exhibit the nature of liquid more than that of the gas. That is why at lower temperatures, you know, from a particular temperature, at lower temperatures than them, you can apply pressure easily and you know, lower the temperature, less is the pressure, that is different thing, but you can apply pressure easily and convert them into gases, but before, above this you cannot. So that is known as a critical temperature. That is known as critical temperature. The temperature below which, above which, or we can say the minimum temperature above which you apply, how much the gas will not be liquefied, no matter what pressure is applied, no matter how greater pressure is applied, okay, that temperature is known as critical temperature. Means at 30.98 degrees Celsius for CO2, at 30.98 degrees Celsius for CO2, even if you apply high pressures, it will not. At 30.97 it will, but at 30.98 it will. Now the pressure that you are applying at critical temperature is known as critical pressure, and the volume occupied by the gas at critical temperature is known as critical volume. That you should remember. So this is what I wanted to make you understand. Then there is a curve known as Andrews curve. Now I will show the Andrews curve from my book. Here is the Andrews curve. Now if you look into the Andrews curve, you see a very complex curve in front of you. But just to understand, these are known as isotherms because this is at one constant temperature. This experiment is conducted at one constant temperature. I'll explain it. Suppose at the point A, look at this. Suppose at the point A, it is at gaseous state. Now you have increased the pressure বাড়াচ্ছিস, volume কমতেছে, pressure বাড়াচ্ছিস, volume কমতেছে. At this particular pressure, okay, what is happening at 31 you are experimenting at 13.1 degrees Celsius. Now it has got started converting into liquid. Now when it has got started converting into liquid at that particular pressure, that particular pressure, which is the pressure for 31.1 degrees Celsius, it will convert into liquid. Tarpore, if you increase the pressure, you will not see that much volume change, the decrease in the volume. See, volume has decreased, and here also the volume has decreased. Obviously gases থেকে liquid volume is less, or gases থেকে liquid density is more, so the volume will decrease. And after that, even if you apply pressure, the effect of pressure does not compress liquid, so it doesn't, the volume is not much decrease, but a steep decrease, a little bit decrease in the volume is noticed because it is moving up like this. Pressure is continuously increasing, but the decrease in the volume is not much. If I join it here, from here to here, the decrease of the volume is not much more. Here to here, see, if it is increased like this, and if you join here, from here to here, the decrease in the volume is not much more. Right or wrong? If this experiment only you are doing at a little bit higher temperature, if you apply pressure, the steep will be higher because at higher temperature you are applying pressure, it is going, and then it will convert into liquid at a particular pressure, and then it will be liquid. Now when you are moving higher and higher and higher in temperature, at lower temperature what is happening? As I said, at lower temperature the density of the liquid is more and the density of the gas is less. And when you are moving higher in temperature, this represents this dome shaped curve represents the liquid plus gas interface, okay, or the coexistence of the equilibrium between liquid and gas. And as you move higher, the density of the liquid, as you move higher in temperature, the density of the liquid becomes less, or the molecule leaves its liquid, the substance tries to shunt off or leave its liquid nature and shift into the gaseous nature. And what happens is the liquid gas interface keeps on decreasing, and at a particular temperature you will not, it has got reduced into a point, you will not find a point here now, or the temperature is so high that the liquid has lost its identity and the gas has over dominated. Now if you apply how much pressure, it is not its nature in that temperature, the nature of the substance is only not there. This is a curve of CO2. The nature of the substance is only not there, that below this temperature the molecules will try to attain the density of liquid. It will not. It will be in gas, and hence how much pressure you apply, it will be compressed but not converted into liquid. Now tell me, did you understand this explanation? So this is the critical temperature. See? Now tell me you understood this or not. I am again saying, if you have not understood, this experiment is going on at less temperature, little higher temperature. At this what happens? You apply pressure. Due to the pressure it got converted into liquid. Apply pressure, got converted into liquid. But the liquid and vapor phase, or the liquid and gas phase that exists, okay, the liquid and vapor phase, or the liquid or gas phase that exists here, okay, what happens is the more is the temperature, more is the tendency of the substance to stay in gaseous state. Hence the distance of the liquid and gas state is not there, is continuously decreasing off, and that's why the curves is becoming steeper and steeper above, lesser and lesser above. And at a point, at this temperature, it will just touch, and above this temperature, though, no chance that the liquid state will exist. So it will not get converted into liquid also. So that is the concept of critical temperature. Did you understand? Suraksha says yes. So if you have understood this, the class is up to this much. Thank you. Your chapter is over. Chapter Khatam. Thank you.